Imagine you're driving a car. You press the accelerator and you speed up. Press harder, go faster. Simple, right? Now imagine, no matter how much fuel you add, no matter how powerful your engine becomes, no matter if you had all the energy in the entire universe at your disposal, there's a speed you can never, ever reach. Not because of friction, not because of engineering, but because the universe itself has a law more fundamental than gravity, more absolute than anything you've ever encountered. That speed is 299,792,458 meters per second. The speed of light. And here's what will absolutely shatter your understanding of reality. This isn't just a speed limit for light. It's a speed limit for information, for cause and effect, for literally everything. And the reason why nothing can break this barrier is so strange, so counterintuitive, that when Albert Einstein first proposed it in 1905, even the greatest minds of his time thought he'd lost his mind. But here's the really mind-blowing part. I'm going to prove to you today, the speed of light isn't actually about light at all. Light just happens to travel at this speed, because photons have no mass. What we call the speed of light is actually the speed of causality itself, the maximum speed at which cause and effect can propagate through the universe. It's the universe's refresh rate. The cosmic speed limit isn't keeping things from going fast. It's holding the fabric of reality together. And by the end of this journey, you're going to understand why every single thing about your existence, from the ground, beneath your feet to the passage of time itself, depends on nothing ever breaking this limit. Because if something could go faster than light, it wouldn't just break physics. It would break logic, causality, and the very concept of before and after. Before we dive deeper into this cosmic rabbit hole, do me a favor, smash that like button if you're ready to have your mind completely rewired. Hit subscribe, because this is just the beginning of understanding how reality actually works. And drop a comment telling me what country you're watching from and what time it is right now. I'm curious to see this community of reality seekers spanning the globe. Now, let's destroy everything you thought you knew about speed. Let's start with something that seems obvious: speed. You learned in school that speed equals distance divided by time. If you drive 60 miles in 1 hour, you're going 60 miles per hour. Want to go faster? Cover more distance in the same time. Simple math that's worked since humans started moving. Now here's where things get weird. In 1887, two scientists named Albert Michelson and Edward Morley conducted what should have been a boring experiment. They wanted to measure how fast Earth was moving through the ether, a substance scientists at the time believed filled all of space, like an invisible ocean that light waves traveled through. Think of it like this. If you're swimming in a river, you move faster when swimming downstream and slower when swimming upstream, right? Scientists expected the same thing with Earth moving through the ether. When Earth moves toward light, we should measure light going faster. When Earth moves away from light, we should measure it going slower. They built an incredibly precise instrument called an interferometer. They measured the speed of light in different directions as Earth orbited the Sun. And what they found made no sense whatsoever. The speed of light was exactly the same, no matter which direction they measured, no matter how fast Earth was moving, no matter what time of year it was. It was like measuring the speed of a river and getting the same answer whether you're swimming upstream, downstream, or standing still. It violated everything they knew about motion and speed. The experiment was so disturbing that Michelson himself was disappointed. He thought he'd failed. But he hadn't failed. He'd just discovered something so profound that it would require completely rebuilding our understanding of space and time. The ether didn't exist, and light didn't follow the rules of normal objects. For 18 years, this result haunted physics. Scientists tried to explain it away. Maybe Earth dragged the ether with it. Maybe the apparatus contracted in the direction of motion. Every explanation created more problems than it solved. Then, in 1905, a 26-year-old patent clerk in Switzerland named Albert Einstein published a paper that would change everything. He wasn't trying to explain the Michelson-Morley experiment specifically. He was thinking about something deeper. What if the speed of light being constant wasn't a weird coincidence, but a fundamental law of nature? Einstein made a wild proposal. What if speed doesn't work the way we think it does? What if when you try to add velocities together, they don't simply add up? What if there's something strange happening to space and time themselves that keeps light moving at the same speed for everyone, no matter how fast they're moving? His solution required accepting something absolutely insane. Time is not universal. Space is not fixed. When you move faster, time actually slows down for you, and space actually contracts. Not because of some mechanical effect, but because that's how the universe fundamentally works. Here's what's about to blow your mind. You know how you experience time? Steady, constant, ticking away at the same rate, whether you're sitting still or running. That's completely wrong. Time is flexible. Time is relative. And the faster you move through space, the slower you move through time. This isn't philosophy. This is measured, proven, experimental fact. In 1971, physicists Joseph Haffel and Richard Keating did something brilliant. They took 4 atomic clocks, the most precise timekeeping devices humans had ever built, and flew them around the world on commercial airplanes. Some flew eastward in the direction of Earth's rotation. Some flew westward against it. They left synchronized atomic clocks on the ground. When the planes returned, they compared all the clocks. And here's what they found. The clocks that flew disagreed with the clocks that stayed on the ground. Not by much, we're talking billions of a second. But they disagreed in exactly the amount Einstein's theory predicted. The clocks that traveled faster through space experienced less time. Time literally passed slower for those clocks. This isn't an illusion. This isn't a measurement error. Time itself moved at different rates. Think of it like this. Imagine the universe has a speed limit for motion through space-time, a combination of space and time. You're always moving through space-time at exactly the speed of light. Always. Right now, as you sit still, you're moving through time at maximum speed. But when you start moving through space, some of that motion through time has to convert to motion through space. Move faster through space? You must move slower through time. It's a trade-off baked into the structure of reality. This is why nothing can reach the speed of light. If you somehow moved through space at light speed, you'd be using 100% of your space-time motion for space. That leaves 0% for time. Time would completely stop for you. From your perspective, you'd reach your destination instantaneously, no matter how far away it was. The entire universe would age around you, but you'd experience 0 time. And here's the kicker. Light itself experiences exactly this. Photons don't experience time. From a photon's perspective, if photons could have perspectives, it's emitted and absorbed in the same instant, even if it travels across the entire universe. 13 billion years might pass for us, but for the photon, 0 seconds. But let's say you want to go faster than light. What would that mean? You'd need more than 100% of your motion through space-time to be through space. You'd need negative time. You'd be moving backward through time. And that's not just weird, that's causality destroying. We'll get to why that breaks the universe in a minute. But first, there's something even stranger we need to understand. Here's where Einstein's theory gets truly bizarre. You know how when you push something, it accelerates? Push a shopping cart, it speeds up. Push harder, it speeds up more. Basic physics, right? But Einstein realized something incredible. As objects move faster, they don't just experience time dilation. They also become harder to accelerate. It's as if they're getting heavier, not because they're gaining atoms or matter, but because their energy is increasing. And in Einstein's universe, energy and mass are the same thing. You've heard of EMC. That's Einstein's most famous equation. It tells us that energy and mass are interchangeable. They're two forms of the same thing. Mass is just incredibly concentrated energy, and energy can behave like mass. Here's what this means for speed. As you accelerate an object faster and faster, you're adding energy to it. That energy increases the object's relativistic mass, the resistance it has to further acceleration. The closer you get to light speed, the more energy is required for each additional increment of speed. And the more energy you add, the more the object resists further acceleration. Let me give you an analogy. Think of it like pushing a shopping cart through an increasingly thick fluid. At normal speeds, you're pushing through air easy. Go faster, and it's like pushing through water harder. Go even faster, and it's like pushing through honey much harder. As you approach light speed, it's like the universe becomes infinite molasses. Every tiny increase in speed requires exponentially more energy. Physicists at CERN, the European Organization for Nuclear Research, demonstrate this every single day. They have a massive particle accelerator called the Large Hadron Collider, a ring 27 kilometers in circumference, buried underground near Geneva, Switzerland. In this machine, they accelerate protons to 99.9999991% the speed of light. Let me repeat that. 99.9999991%. They're pushing these tiny particles to speeds where they're zipping around the ring about 11,000 times per second. At these speeds, the protons have so much energy that they act as if they're about 7,000 times heavier than when they're at rest. But here's the thing. No matter how much more energy they pump into the system, they can never get those protons to actually reach light speed, let alone exceed it. They can get to 99.99999999999% the speed of light, but never 100%. It's like trying to count to infinity. You can keep adding nines, but you'll never actually arrive. And the reason is mathematical and absolute. According to Einstein's equations, to actually accelerate any object with mass to the speed of light would require infinite energy. Not a lot of energy. Not more energy than exists in the universe. Literally infinite energy. Think about what that means. You could harness every star in every galaxy. You could convert every atom in the observable universe into pure energy. You still wouldn't have enough to push a single electron to light speed. The universe itself doesn't contain enough energy to break its own speed limit. But wait, it gets stranger. What if you're already moving at 99% light speed, and then you fire a rocket that accelerates you by another 50% in your reference frame? You'd think you'd be going 149% light speed now, right? Wrong. Here's where velocities stop adding up the way you'd expect, and reality gets really weird. Let's talk about what happens when you try to break the speed limit. Imagine you're on a spaceship traveling at 90% the speed of light. You're holding a flashlight. You turn it on. Common sense says the light should leave your flashlight at light speed relative to you, plus 90% light speed from your ship's motion. So someone watching from Earth should see that light traveling at 190% the speed of light, right? Nope. They see it traveling at exactly light speed. 299,792,458 meters per second. Not a meter per second faster. How is this possible? How does the universe conspire to make sure light always travels at the same speed, regardless of how fast its source is moving? The answer is so elegant and so disturbing that it changes everything. Time and space themselves adjust. For you on that spaceship, time is moving slower and space is compressed in the direction you're traveling. These effects precisely cancel out any addition of velocities in a way that ensures light always moves at light speed for everyone. Einstein gave us a formula for adding velocities in his theory of special relativity. It looks like this. If you're moving at velocity u and you fire something at velocity v, the combined velocity w isn't u plus v. Instead, it's W equals U plus V slash 1 plus UVC squared, where c is the speed of light. For everyday speeds, that denominator is basically 1, so velocities add normally. But as you approach light speed, that denominator grows, making the result always less than c. No matter what velocities you plug in, even if both u and v are 99.99% light speed, the result is always less than light speed. It's like the universe has a mathematical protection mechanism built into the very fabric of spacetime. You cannot, even in principle, add velocities in a way that exceeds light speed. But here's where it gets truly mind-bending. This isn't just about objects you can touch. It's about information itself, about cause and effect, about the very concept of now. See, in Einstein's universe, there's no such thing as absolute simultaneity. Events that appear simultaneous to you might not appear simultaneous to someone moving relative to you. Your now is different from their now, and this is only possible because nothing can travel faster than light. Let me explain with an example. Imagine you're standing in the middle of a train car. You turn on a light. The light expands as a sphere, reaching the front and back of the car at the same time because you're equidistant from both ends. Simultaneous events. But someone standing on the platform watching the train zoom by sees something different. From their perspective, the back of the train is moving toward the light and the front is moving away from it. So they see the light hit the back wall before it hits the front wall. Not simultaneous. Who's right? Both of you. There is no universal now. Simultaneity is relative. Events that are simultaneous in one frame of reference are not simultaneous in another. And here's the disturbing part. This only works because light speed is the same for everyone. If you could send information faster than light, you could create situations where effects precede causes, where you receive a message before it's sent, where you can change the past. We're not talking about time travel movies. We're talking about the logical structure of cause and effect collapsing. And I'm about to show you exactly how that happens. This is where things get truly disturbing. Let me show you why faster than light travel doesn't just break physics, it breaks logic itself. Imagine you have a faster than light phone. You're on Earth, and your friend is on a spaceship moving away from Earth at 80% light speed. You make a call using this FTL phone in noon your time. From your reference frame, the call arrives instantly at your friend's ship. They receive it at noon, Earth time. No problem, right? But here's the issue. Your friend on the spaceship experiences time differently than you. Their now is different from your now because they're moving so fast. From their perspective, when they receive your call, it's not noon Earth time. It might be 11 a.m. Earth time from their skewed reference frame. Now your friend immediately calls you back using the same FTL phone. From their perspective, they're calling you immediately after receiving your call. But remember, their now is different from your now. When the FTL call arrives back at Earth, it arrives at 10 a.m. your time 2 hours before you made the original call. You've just received a response before you sent the message. Effect has preceded cause. The universe's logical structure has collapsed. This isn't a thought experiment with questionable assumptions. This is a direct mathematical consequence of special relativity combined with faster-than-light signaling. Any method of sending information faster than light, whether it's a phone call, a spaceship, or a talking beam, creates the possibility of causality violation. And causality violation doesn't just mean you could kill your grandfather before your father is born. Paradoxes like that might have some weird quantum resolution. No, causality violation means the very concepts of cause and effect become meaningless. It means you could press a button that prevents that same button from ever being pressed. It means logical contradictions become physically possible. The universe, it seems, cannot allow this. And the speed of light isn't just a speed limit, it's a causality protection mechanism. It's the universe's way of maintaining a consistent past and future. In 1967, physicist Gerald Feinberg proposed the existence of tachyons, hypothetical particles that always move faster than light. Mathematically, they're allowed by the equations if you're willing to accept that they have imaginary mass, as in the square root of a negative number. But every attempt to incorporate tachyons into physics has led to causality violations and logical contradictions. Most physicists now believe tachyons don't exist precisely because they would break causality. The universe seems to have a built-in prohibition against them. Every time we've looked for them experimentally, we've found nothing. The speed of light stands as an absolute barrier, not just for matter and energy, but for information and causality itself. Here's something that will really bake your brain. Even quantum entanglement, that spooky action at a distance Einstein hated, doesn't violate the light speed limit. When you entangle two particles and separate them, measuring one instantly affects the other, even if they're light years apart. But you cannot use this to send information faster than light. The results look random until you compare them through classical communication channels that are limited by light speed. The universe protects causality with zealous fervor. Every loophole you can think of, wormholes, warp drives, quantum tunneling, either doesn't actually allow faster than light information transfer or requires exotic matter with negative energy that probably doesn't exist, or creates time machines that lead to their own paradoxes. The speed of light isn't just a limit on speed. It's the firewall protecting reality from logical contradiction. And that's not even the strangest part of this story. Now I'm going to tell you something that's going to fundamentally change how you think about light. Remember how I said that as you approach light speed, time slows down for you? Well, what happens when you actually reach light speed? Time stops completely. From a photon's perspective, time does not pass. A photon emitted from a star 13 billion light-years away experiences no time between its emission and its absorption by your eye. From your perspective, that photon traveled for 13 billion years. From the photon's perspective, zero time, instantaneous. Think about what this means. Every photon that has ever existed experiences the entire history of the universe as a single moment. The Big Bang, the formation of galaxies, the birth of Earth, your grandmother's childhood, and the moment you're reading this, all the same instant from light's perspective. This is why light can travel at the speed limit. Light doesn't have mass. Photons are massless particles, which means they don't experience the relativistic mass increase that makes it impossible to accelerate massive particles to light speed. In fact, photons can only travel at light speed. They can never be at rest. They're born moving at 299,792,458 meters per second, and they die moving at that exact same speed. But here's what's truly profound. The speed of light isn't actually about light. Light just happens to travel at this speed because photons are massless. The real significance of c, the symbol physicists use for the speed of light, is that it's the speed of causality. It's the maximum speed at which information can propagate through spacetime. Anything with no mass must travel at this speed. Light does. Gravity does too. If the sun suddenly vanished, Earth wouldn't immediately fly off into space. We'd continue orbiting for about 8 minutes. The time it takes for the gravitational information the sun is gone to reach us at light speed. Gravitational waves ripples in spacetime itself also travel at exactly light speed. In 2017, LIGO, the Laser Interferometer Gravitational Wave Observatory, detected gravitational waves from 2 neutron stars colliding 130 million light-years away. About 1.7 seconds after detecting the gravitational waves, telescopes saw the light from the same collision. The waves and the light traveled across 130 million light-years and arrived within 2 seconds of each other. This confirmed that gravity and light travel at the same speed, the speed of causality. Think of it like this. C is the speed limit of the universe's operating system. It's the maximum rate at which the universe can update itself. It's like the refresh rate of reality. Anything that carries information, whether it's light, gravity, or anything else, is bound by this update speed. But here's something that might surprise you. In some materials, light actually travels slower than c. When light moves through glass or water, it interacts with the atoms in the material, and this slows it down. Light in water travels at about 75% of c. Light in diamond travels at about 40% of c. Does this mean we can go faster than light? No, because we're talking about light's effective speed through matter, not the fundamental speed limit c. The individual photons still travel at light speed between atoms. They're just constantly absorbed and re-emitted, which creates a delay. The fundamental cosmic speed limit, the speed of causality, remains unchanged. And here's a mind-blowing consequence. In certain materials, particles can travel faster than the local speed of light in that material, even though they're still traveling slower than c in vacuum. When this happens, the particle creates a shock wave of light called Cherenkov radiation. It's like a sonic boom, but for light. Nuclear reactors glow blue because of Cherenkov radiation from fast particles traveling through water, faster than light travels through water. But nothing can travel faster than c in vacuum. That's the absolute limit. Or is it? There's one thing in the universe that seems to break this rule, and it's going to flip everything we've discussed on its head. Here's where I'm going to tell you something that seems to contradict everything we've discussed. There are galaxies in the universe that are moving away from us faster than the speed of light. Wait, what? How is that possible? The answer reveals something profound about what the speed limit really means. See, the speed of light limits how fast things can move through space. But it doesn't limit how fast space itself can expand. In 1929, astronomer Edwin Hubble discovered something shocking. Distant galaxies are moving away from us, and the farther away they are, the faster they're receding. This isn't because they're physically traveling through space away from us. It's because space itself is expanding, carrying the galaxies with it. Imagine you have a balloon with dots drawn on it. As you inflate the balloon, the dots move apart from each other. But the dots aren't moving across the surface of the balloon. The surface itself is stretching. That's what's happening with the universe. Space itself is expanding. And here's the kicker. There's no speed limit on how fast space can expand. The speed of light limits motion through space, but space itself can expand as fast as it wants. Currently, galaxies more than about 14 billion light years away are receding from us faster than light speed due to the expansion of space. Does this violate relativity? No, because these galaxies aren't moving through space faster than light space is expanding between us. From each galaxy's local perspective, nothing is moving faster than light. Special relativity only applies to local motion through space, not to the expansion of space itself. This is why there's a cosmic horizon, a distance beyond which we can never see, no matter how long we wait. Light from galaxies beyond this horizon is traveling toward us at light speed, but space is expanding between us faster than the light can close the gap. It's like running on a treadmill that's accelerating faster than you can run. You're running forward at maximum speed, but you're still moving backward relative to someone watching from outside the treadmill. The observable universe is about 46.5 billion light years in radius, even though the universe is only 13.8 billion years old. How can we see things 46.5 billion light years away if light has only had 13.8 billion years to travel? Because those objects were much closer when they emitted the light we're now seeing, and space has been expanding ever since. The objects themselves have been carried away from us by expanding space. And it gets weirder. The expansion is accelerating. In 1998, two teams of astronomers, led by Saul Perlmutter, Brian Schmidt, and Adam Rees discovered that the universe's expansion is speeding up. They won the Nobel Prize in Physics in 2011 for this discovery. Something called dark energy is pushing space to expand faster and faster. This means that over time, more and more galaxies will cross that cosmic horizon and disappear from our view forever. In trillions of years, if you are still around, you'd look up at the night sky and see only our local galaxy cluster. Everything else would have been carried beyond the horizon by the expanding space. Future civilizations might conclude they live in a universe with only one galaxy cluster, having no way to discover all the galaxies we can still see today. But here's the important thing. Even though space can expand faster than light, you still can't use this to travel faster than light relative to your local space. You can't surf the expansion of space to break the speed limit. The limitation on motion through space remains absolute. And this brings us to one of the most mind-bending implications. Your past and future are not what you think they are. Here's something that's going to change how you think about time forever. In classical physics, the physics of Newton, the universe is like a movie that's already been filmed. The past is fixed, the present is happening, and the future is already determined, just waiting to unfold. If you knew the position and velocity of every particle in the universe, you could calculate everything that would ever happen. But relativity destroys this picture completely. In Einstein's universe, the future isn't just unknown, it's literally undefined. And the speed of light is what creates this openness. Think about it this way. Nothing can travel faster than light, which means information about events happening right now can only reach you at light speed or slower. Events happening on the sun right now? You won't know about them for 8 minutes. Events happening in the Andromeda galaxy? You won't know about them for 2.5 million years. But here's the twist. Because of the relativity of simultaneity, what counts as right now depends on your motion. Events that are happening now in your reference frame are different from events happening now for someone moving relative to you. Your present moment is different from theirs. This means that the set of events that could potentially affect you right now, your past light cone, as physicists call it, is different from someone else's past light cone. And the set of events you could potentially affect your future light cone is also different. In relativity, space-time is divided into regions for every event. There's the past light cone. All events that could have potentially affected this moment, because they're close enough in space and far back enough in time that light could have traveled from them to here. There's the future light cone. All events this moment could potentially affect, because they're close enough in space and far forward enough in time that light could travel from here to them. And then there's the massive region outside both cones. Events that are too far away in space and too close in time for light to connect them to you. These events are called space-like separated from you. They can't affect you, and you can't affect them. And because of the relativity of simultaneity, different observers will disagree about whether these events are in the past, present, or future. Here's the truly mind-blowing part. There are events happening right now in distant galaxies that are in your present moment from one reference frame, in your past from another reference frame, and in your future from yet another reference frame. The ordering of events isn't absolute unless they're connected by a light speed or slower signal. This means the future isn't sitting out there waiting to happen. The future is being created by the propagation of causal influences at light speed. Reality is constantly crystallizing out of possibility as light speed influences propagate outward from every event. Think about what this means for free will. In Newton's clockwork universe, determinism meant the future was already fixed, even if we couldn't calculate it. But in Einstein's universe, there's a fundamental openness to the future. Events outside your light cone haven't happened yet from your perspective, because they can't affect you yet. The universe is more like an unfolding flower than a pre-recorded movie. And here's something that will really bake your brain. According to quantum mechanics, this gets even weirder. Quantum mechanics tells us that particles don't have definite properties until they're measured. Combine this with relativity, and you get quantum field theory, the framework that describes particle physics. In quantum field theory, particles are excitations in fields that permeate all of space, and these excitations propagate at or below light speed. The speed of light isn't just a limit on matter and energy. It's a limit on how fast possibility becomes actuality. It's the speed at which the universe decides what's real. But wait, if the speed of light is so important, where does it come from? Why is it exactly 299,792,458 meters per second and not some other number? The answer is going to surprise you. Here's something that might shock you. The speed of light is kind of arbitrary. Not in the sense that it could be different, but in the sense that the specific number 299,792,458 meters per second is based on human-defined units. Meters are an arbitrary human invention. Seconds are an arbitrary human invention. Of course, the speed of light would be an arbitrary number when measured in arbitrary units. In fact, as of 2019, the meter is officially defined in terms of the speed of light, not the other way around. 1 meter is defined as the distance light travels in 1/299th, 792,458 of a second. We've essentially fixed the speed of light at exactly 299,792,458 meters per second by definition, and we use that to define what a meter is. But here's what's not arbitrary: the speed of light in relation to other fundamental constants of nature. See, the speed of light emerges from two properties of empty space. Its electric permittivity, how easily it can support electric fields, and its magnetic permeability, how easily it can support magnetic fields. Back in the 1860s, Scottish physicist James Clerk Maxwell unified electricity and magnetism into one theory, electromagnetism. His equations predicted that oscillating electric and magnetic fields could propagate through space as waves. When he calculated how fast these waves should travel, he got a number around 310,740 kilometers per second, very close to the measured speed of light. Maxwell realized light is an electromagnetic wave, and the speed of electromagnetic waves emerges from the electric and magnetic properties of the vacuum. The speed of light isn't a separate fundamental constant. It's a consequence of deeper properties of spacetime itself. In modern physics, we often don't even talk about the speed of light as a fundamental constant. Instead, we use units where c equals 1. In these natural units, time and space have the same dimensions. 1 second equals 1 light second of distance. Energy and mass have the same dimensions because E equals mc squared. In these units, the speed of light is just 1. It's not fast or slow. It's just the conversion factor between space and time. It's like asking, how many meters are in a meter? The answer is 1, by definition. This reveals something profound. The speed of light is really telling us about the geometry of spacetime. It's telling us that space and time are not separate things, but aspects of a unified spacetime. The speed of light is the conversion factor between the spatial dimensions and the time dimension of spacetime. Here's an analogy. Imagine you're measuring a slope. You could say, this hill rises 30 meters over 60 meters of horizontal distance. The slope is 0.5. But you could also measure in feet and get a different number. The number changes, but the slope itself, the geometrical relationship, doesn't. Similarly, the numerical value of the speed of light changes depending on your units, but the fundamental geometrical relationship it represents is universal. What would a universe with a different speed of light look like? Well, it would be a universe with different electromagnetic properties of the vacuum. Atoms would be different sizes. Chemistry would be different. Stars would burn differently. The universe would be fundamentally different in ways that would likely make life impossible. Some physicists have proposed that the fine structure constant, a dimensionless number around 1/137th, that governs the strength of electromagnetic interactions, might vary across space or time. If this constant changed, it would effectively change the speed of light relative to other processes. Astronomical observations looking at light from distant quasars have found no evidence of such variation, but it remains an open question. The key point is this: the speed of light isn't some arbitrary speed limit the universe decided to impose. It's a fundamental aspect of space-time geometry. Asking, why is the speed of light what it is like asking, why does space-time have the geometry it has? And that's a question that touches on the deepest mysteries of physics. Speaking of which, there's one more mind-blowing thing about the speed of light that connects to the very birth of the universe itself. Let me take you back to the very beginning. 13.8 billion years ago, the universe began with the Big Bang. But here's something that will twist your brain. In the first fraction of a second after the Big Bang, the universe underwent a period of cosmic inflation, a period where space expanded faster than the speed of light. Wait, didn't I just spend all this time explaining why nothing can go faster than light? Here's the thing. Inflation didn't violate relativity because, just like the current expansion of the universe, inflation was an expansion of space itself, not motion through space. During inflation, which lasted from about 10 seconds to 10 seconds after the Big Bang, the universe doubled in size at least 60 times, possibly many more. Each doubling took an incredibly tiny fraction of a second. In less time than it takes light to cross the nucleus of an atom, the universe expanded from smaller than a proton to potentially as large as a grapefruit, or even much larger. This expansion happened much, much faster than the speed of light. But crucially, no information or particle traveled through space faster than light. Space itself was expanding, carrying everything with it. Why did this happen? The leading theory is that inflation was driven by a quantum field called the inflaton field. This field had enormous energy density, which caused space to expand exponentially. Eventually, the inflaton field decayed, releasing its energy and creating all the matter and energy in the universe. The hot, dense state we call the beginning of the hot Big Bang. But here's the truly mind-bending part. Before inflation, the observable universe, everything we can see in all directions, was smaller than an atom. It was so small that quantum effects governed its behavior. The entire universe was subject to quantum uncertainty. And quantum fluctuations during inflation, tiny random variations in the inflaton field, were stretched out by the expansion of space. These quantum fluctuations became the seeds of cosmic structure. They became the density variations that eventually grew into galaxies, stars, and planets. Everything in the universe, the galaxy cluster you're part of, the local group, the Virgo supercluster, the cosmic web of large-scale structure, all of it traces back to quantum fluctuations in a field during a period lasting less than a trillionth of a trillionth of a trillionth of a second. And the speed of light? It set the scale for how these fluctuations evolved. Causal processes that could affect each other were limited by light speed. Regions of space that inflated from points originally separated by more than a light travel distance couldn't influence each other. This is why the cosmic microwave background, the afterglow of the Big Bang, has a particular pattern of hot and cold spots. These spots represent regions that were causally connected before inflation, and regions that weren't. The size of the largest spots corresponds to the distance light could have traveled in the very early universe before inflation. It's literally a map of causality written across the sky. In 2016, the LIGO collaboration detected gravitational waves for the first time, ripples in space-time itself traveling at the speed of light, produced by two black holes colliding 1.3 billion light-years away. These waves passed through Earth, compressing and stretching space by less than the width of a proton. The detection confirmed that gravity, the curvature of space-time, propagates at exactly light speed, just as Einstein predicted. But there's something even more profound we need to understand. The speed of light doesn't just limit how fast things can go. It limits how much you can know. And that brings us to one of the most disturbing implications of all. You are causally isolated from most of the universe. Here's a disturbing thought that I need you to really sit with. Because of the speed of light and the expansion of the universe, you are fundamentally isolated from most of existence. Remember the cosmic horizon I mentioned earlier? Galaxies beyond a certain distance are receding from us faster than light due to the expansion of space. Light from these galaxies will never reach us, no matter how long we wait. In a very real sense, those galaxies are not part of our universe, not because they don't exist, but because we are causally disconnected from them forever. But it gets worse. Due to the accelerating expansion of the universe, driven by dark energy, this horizon is not just a feature of the distant past, it's closing in on us. More and more galaxies are crossing this horizon every moment. Over trillions of years, entire galaxy clusters will disappear from view, their light forever unable to reach us because space is expanding too fast between us. Eventually, in the far future, we're talking 100 trillion years or more, an observer in our galaxy would look out and see nothing but darkness. The cosmic microwave background would be redshifted into invisibility. All other galaxies would have disappeared beyond the horizon. They would have no way to discover that other galaxies even exist. They would think they live in a universe containing only their own island of stars, surrounded by infinite darkness. And here's the truly disturbing part. All the evidence for the Big Bang, for cosmic expansion, for dark energy, all of it would be gone. Future cosmologists would have no way to figure out the history of the universe. The universe would have erased its own past. This is called the cosmic dark age, and it's our future if the acceleration continues. We live in a special time, perhaps the only era where the universe is both old enough for intelligent life to evolve and young enough for that life to see the broader cosmos and figure out its history. But let's bring this back to you, here and now. Because of the light speed limit, you are isolated even from events happening right now. When you look at the sun, you're seeing it as it was 8 minutes ago. When you look at Alpha Centauri, you're seeing it as it was 4.4 years ago. When you look at the Andromeda Galaxy, you're seeing it as it was 2.5 million years ago. You can never see anything as it is now. You can only see its past. Your now exists only in your immediate vicinity, within the infinitesimal light travel time of your brain. Everything else you perceive is history. And it's not just that you see the past, it's that there's no universal now that includes you and distant events. The concept of what's happening in Andromeda right now is literally undefined. Different observers moving at different velocities would disagree about what events in Andromeda are happening now. This means you are trapped in a tiny bubble of spacetime, your light cone, forever expanding outward at light speed, but never encompassing the whole universe. You are an island of causality in a vast ocean of spacetime, most of which you can never interact with, never know about, never affect, or be affected by. But here's where this gets personal and profound. This isolation isn't a limitation. It's what makes your existence meaningful. And understanding this completely changes how you should think about your place in the cosmos. For the last 2.5 hours, I've been explaining why nothing can go faster than light, how the speed of causality is baked into the structure of spacetime, how it protects cause and effect from collapsing into paradox, how it defines the boundary between past and future. But now I want to tell you why this matters to you personally. Why the speed of light, this abstract cosmic speed limit, is actually one of the most important facts about your existence. First, let's start with something simple. You are made of atoms that were forged in the hearts of stars. The carbon in your cells, the iron in your blood, the oxygen you breathe, all of it was created in nuclear fusion reactions deep inside stars that lived billions of years ago, then exploded as supernova, scattering these elements across space. Those elements drifted through space for millions of years before they came together in the cloud of gas and dust that formed our solar system 4.6 billion years ago. You are literally made of stardust, not as a poetic metaphor, but as a physical fact. But here's what the speed of light adds to this story. Those atoms traveled through space for millions or billions of years to reach here. But from the photon's perspective, from the perspective of the light carrying information about these stellar explosions, no time passed at all. The explosion and the present moment are the same instant. You exist at the intersection of countless causal chains, all limited by the speed of light, stretching back to the Big Bang itself. Every atom in your body has a history that spans billions of years and light years of space. You are not separate from the universe. You are a temporary pattern in the flow of matter and energy that has been propagating through space-time since the beginning of time, always limited by, always shaped by, the speed of light. Second, consider what the speed of light means for consciousness and experience. You are not a single unified thing experiencing reality in real time. The nerve impulses in your body travel at speeds far, far slower than light, maybe 100 meters per second for the fastest neurons. Light takes about a nanosecond to travel the length of your body, but nerve impulses take tens of milliseconds. This means your brain is constantly constructing a model of reality from information that arrives at different times. Touch your toe, you feel it immediately, but that's an illusion. The signal takes time to travel up your spine to your brain. Your consciousness is experiencing the past and stitching together signals from different times into the illusion of a coherent now. But here's the profound part. You are not experiencing reality. You are experiencing your brain's model of reality, a model constructed from light-speed limited information filtered through sensory organs, transmitted by chemical and electrical signals, and interpreted by neural networks that evolved over millions of years. You are always, fundamentally, experiencing the past and predicting the present. Third, and this is the big one, the fact that nothing can go faster than light means that cause and effect are protected. It means your choices matter. It means the universe is not predetermined, because information about distant events hasn't reached you yet. It means the future is genuinely open. In a universe where faster than light travel was possible, causality would break down. You could affect your own past. You could create logical paradoxes. Cause and effect would become meaningless. But in our universe, where c is the ultimate speed limit, your past is fixed, your present is yours, and your future is open. Every choice you make creates ripples in space-time that propagate outward at the speed of light, affecting future events in your light cone. Your light cone is your sphere of influence. Everything you could possibly affect, everything you could possibly know about. And it's growing every second, expanding at 300,000 kilometers per second in all directions. Everything you've ever said, every light you've ever turned on, every word you've ever written, those influences are expanding outward through space at light speed, slowly but inexorably spreading to more and more of the universe. In principle, if someone had a telescope powerful enough and was far enough away, they could see Earth as it was when you were born. The light from that moment is out there, carrying information about your existence, spreading through the cosmos forever. You are not just in the universe, you are becoming part of the universe's history, written in light, spreading outward at 300,000 kilometers per second. Fourth, let me tell you something that might change how you think about death. When someone dies, they don't disappear from the universe. The light carrying information about their existence is still spreading outward through space. If you could travel far enough, fast enough, if you could cheat relativity, which you can't, you could still see them alive, because the light from when they were alive hasn't reached those distant places yet. In a very real sense, the past doesn't cease to exist, it just becomes inaccessible to us because we move forward through time. But the events themselves, the light carrying information about those events, continues spreading through space-time forever. Every moment of your life is being recorded in the structure of the universe itself, in the pattern of light spreading outward from Earth. This is why physicists like Carlo Rovelli talk about the block universe, the idea that past, present, and future all equally exist, spread out in spacetime like frames in a film. You don't experience them all at once, because you're a process moving through time, but they're all equally real. The speed of light defines the structure of this block universe, determining which events can affect which other events. Fifth, consider the sheer scale of what we've been discussing. The observable universe is about 93 billion light years across. That's 880 trillion kilometers. Light from the most distant galaxies we can see has been traveling for 13.4 billion years, almost as old as the universe itself. And yet, despite this unimaginable vastness, everything in it is connected by the same speed limit. The same law that prevents you from traveling faster than 300,000 kilometers per second also governed the propagation of density fluctuations in the early universe, the formation of the first stars, the evolution of galaxies, and ultimately, the existence of planets where life could evolve. You are connected to the most distant quasar, to the cosmic microwave background, to the moment of the Big Bang itself, through an unbroken causal chain limited by the speed of light. This isn't mysticism, this is physics. You are causally connected to everything in your past light cone, which includes events from across billions of light years of space in billions of years of time. Sixth, let me tell you about the Fermi paradox in a new light. Enrico Fermi famously asked, "Where is everybody? If the universe is so vast and so old, why haven't we seen evidence of alien civilizations?" There are many proposed solutions, but here's one that's often overlooked. The speed of light is really, really slow on cosmic scales. Even if there are 1 million civilizations in our galaxy right now, and even if they're broadcasting signals in all directions, those signals spread outward at light speed. Our galaxy is 100,000 light years across. If a civilization on the other side of the galaxy started broadcasting 50,000 years ago, their signals are only halfway here. We wouldn't hear them for another 50,000 years. And if they're looking for us, they see Earth as it was thousands of years in the past, before we had radio technology. We are separated not just by space, but by the light speed delay that makes our nows different. The speed of light doesn't just limit travel, it limits communication, knowledge, coordination. It makes the universe a lonely place, where civilizations can exist in the same moment, but be unable to ever contact each other due to the sheer distance and the absolute speed limit. But perhaps that's not a bug, it's a feature. Perhaps the speed limit exists to preserve the independence and uniqueness of different regions of spacetime. Perhaps it prevents a single civilization from dominating the entire universe. Perhaps it ensures that life, wherever it emerges, must develop on its own, must solve its own problems, must create its own meaning. Which brings me to my final point, the one I want you to really internalize. You exist in a universe with a speed limit, and that means you exist in a universe with boundaries, with structure, with meaning. In an infinite universe with no speed limit, nothing would be unique. Information could propagate instantly, everywhere. Every event would affect every other event. There would be no locality, no independence, no room for different processes to evolve separately. Cause and effect would be a tangled mess, spanning the entire universe at every moment. But in our universe, with its light speed limit, you are a localized process. You have a region of spacetime that is uniquely yours, your past light cone, containing everything that could have affected you, and your future light cone, containing everything you could possibly affect. You are not infinitely connected to everything. You are finitely connected to a specific region of spacetime, and that's what makes you you. The speed of light creates boundaries, and boundaries create meaning. Without boundaries, there is no distinction, no structure, no information. With boundaries, there is difference, complexity, life, consciousness. You are a pattern of information that has emerged in a specific region of spacetime, bounded by the light speed limit, shaped by causal influences that propagated to you from the Big Bang through 13.8 billion years of cosmic evolution. You are not separate from this process. You are this process, experiencing itself from the inside. And here's the truly profound thing. You are aware of this. You can comprehend the speed of light, understand relativity, grasp the structure of spacetime. You are a piece of the universe that has become complex enough, organized enough to understand the universe itself. You are the universe looking back at itself. Carl Sagan said, "We are a way for the cosmos to know itself, but it's deeper than that." We are a way for the cosmos to understand itself, to comprehend its own laws, its own structure, its own history. The atoms in your brain, forged in ancient stars, are now arranged in such a way that they can understand how stars work, how atoms form, how the universe began. And you can understand why there's a speed limit. You can grasp that the speed of light is not arbitrary, not an inconvenience, but a fundamental aspect of causality, of the relationship between space and time, of the structure that makes existence itself possible. So yes, nothing can go faster than light, not because the universe is limiting you, but because the universe is structured in a way that makes existence meaningful, causality coherent, and your consciousness possible. The speed of light is not a barrier. It's the framework that allows you to exist at all. We've reached the end of this journey, and I want to leave you with one final mind-bending idea that ties everything together. The speed of light, this cosmic speed limit we've spent 3 hours exploring, is ultimately about one thing: the relationship between space and time. And that relationship is telling us something profound about the nature of reality itself. See, in physics, there's a deep principle called gauge invariance. Without getting too technical, it means that the laws of physics don't depend on arbitrary choices we make about how to measure things. You can measure distances in meters or feet, time in seconds or hours. The laws of physics stay the same. But there's a deeper gauge invariance. The laws of physics are the same everywhere in space and time. The speed of light is the same in New York and Tokyo, on Earth and in the Andromeda galaxy, yesterday and today. This universality, this constancy, is not a coincidence. It's a consequence of the universe having consistent laws. In fact, Einstein's entire theory of relativity can be derived from just two postulates. First, the laws of physics are the same in all inertial reference frames. And second, the speed of light is constant for all observers. From just these two simple statements, all of special relativity follows: time dilation, length contraction, mass energy equivalence, the whole thing. But why should the speed of light be constant? What makes it so special? Here's the deep answer, the one that will tie everything together. The speed of light is constant because space-time is a thing, a real physical structure with properties. Space and time aren't just empty containers where events happen. They're a dynamic, flexible medium that can curve, stretch, and ripple. And like any medium, space-time has properties that determine how waves propagate through it. The speed of light is the natural speed at which disturbances propagate through space-time. Just as sound waves propagate through air at a speed determined by air's properties, and water waves propagate through water at a speed determined by water's properties, electromagnetic waves and gravitational waves propagate through space-time at a speed determined by space-time's properties. And that speed happens to be 299,792,458 meters per second. But here's the truly mind-bending part. Spacetime isn't just the stage where physics happens. Spacetime is physics. The curvature of spacetime is gravity. The oscillations of fields in spacetime are particles. The flow through spacetime is time. Everything you experience, matter, energy, force, motion, is ultimately patterns in spacetime. And the speed limit? The speed limit is telling you how fast changes can propagate through this medium. It's telling you the maximum rate at which cause can become effect, at which information can flow, at which the future can crystallize out of the present. In quantum field theory, the deepest description of reality we have, even particles are emergent phenomena. An electron isn't a little ball of stuff flying through space. It's a ripple in the electron quantum field, a disturbance in spacetime with certain properties. And these disturbances propagate at or below light speed, because that's the speed at which changes in the field can propagate. Everything, and I mean everything, is waves in fields, and all of these waves are limited by the speed of light. Now, here's where I'm going to blow your mind one more time. Some physicists, including people like Nobel laureate Frank Wilczek, have suggested that space-time itself might be an emergent phenomenon, something that arises from deeper, more fundamental physics. Just as temperature emerges from the motion of molecules, and wetness emerges from the interaction of water molecules, maybe space-time emerges from something more fundamental. Maybe the speed of light isn't a property of space-time. Maybe space-time is constructed in such a way that the speed of light emerges automatically. What could be more fundamental than space-time? We don't know. Some theories suggest quantum entanglement, the spooky action at a distance Einstein hated. Some suggest information theory, that the universe is fundamentally made of information, and space-time is just the way that information organizes itself. Some suggest something called quantum gravity, where space-time itself is quantized into discrete chunks at the Planck scale 10 meters, smaller than atoms by the same factor that atoms are smaller than the solar system. But whatever the fundamental reality is, whatever lies beneath space-time, one thing is clear: the speed of light will emerge from it. The speed limit isn't arbitrary, it's necessary. It's built into the logical structure of any universe that has causality, that has time, that has change. And that means you, a conscious being made of patterns in space-time, capable of understanding these patterns, are not an accident. You are what the universe does when it organizes itself. You are complexity emerging from simplicity, consciousness emerging from matter, understanding emerging from chaos. The speed of light created the conditions for your existence. The 8-minute delay between the sun and Earth, that's too fast for life on Earth to notice or care about. But the billion-year timescales of stellar evolution, shaped by light speed limits on energy transport inside stars, that's what allowed stars to burn steadily long enough for planets to form and life to evolve. The cosmic horizon, beyond which we can never see, that created the local conditions, a pocket of spacetime we inhabit, where matter density and energy density were just right for galaxies and stars and planets and you. The protection of causality, the impossibility of time travel paradoxes, that created a universe with a coherent past and an open future, a universe where your choices matter and your actions have consequences. Everything about your existence depends on nothing going faster than light. And now you know why. Not just the physics, the deep reason. The speed of light isn't the limitation, it's the framework. It's the structure that holds reality together. It's the reason the universe makes sense, the reason you can exist, the reason there are patterns and order and meaning instead of chaos. So the next time you turn on a light, or look at the stars, or feel the warmth of the sun on your face, remember, you're experiencing the speed of light, you're experiencing causality, you're experiencing the fundamental structure of spacetime itself, and you're experiencing it from the inside as a pattern that has become aware of itself, in a universe that has organized itself to allow such patterns to exist. That's not just physics. That's profound. That's beautiful. That's the universe understanding itself through you. Before we end, I want to ask you one more time. If this journey changed how you see reality, hit that like button. If you want more deep dives into the nature of existence, subscribe. And tell me in the comments, what's the most mind-blowing thing you learned today? What question are you still wrestling with? Because here's the final truth. The speed of light is absolute, but your understanding isn't. You can keep learning, keep questioning, keep pushing the boundaries of what you know. That's what makes you human. That's what makes you matter. The universe has a speed limit, but your curiosity doesn't. Thanks for joining me on this journey through space-time. Until next time, keep wondering, keep questioning, and keep looking up at the stars. They're looking back at you.